Imagine this. Under the familiar night sky, among the countless stars we've always known, suddenly a visitor appears. Not from Earth, not from any planet of our solar system, but from somewhere far beyond. This is 3I divided by Atlas, a rare interstellar comet racing at incredible speed through our cosmic neighborhood. At first, astronomers expected just a faint flicker, maybe a small smudge lost among the stars. But instead, 3I divided by Atlas has exploded in brightness 6 times brighter than predictions. Surrounding its hidden core, a massive green cloud has formed nearly 500,000 kilometers across. To put that in perspective, that's dozens of times larger than Earth, and almost as wide as Jupiter, the giant of our system. This sudden surge of light has stunned both scientists and skywatchers. Could this be nothing more than frozen gases boiling away under sunlight? Or is there something stranger happening deep inside this visitor from another star system? Normally, comets brighten as they approach the Sunday ice, and dust on their surface heat up, evaporate, and form a hazy atmosphere called a coma. But in the case of 3I divided by Atlas, this process is happening far more violently than expected. Spectroscopic measurements show that its vivid green glow comes from molecules of diatomic carbon, C2. Sunlight excites these molecules, and as they relax, they emit that signature emerald light. It's a familiar effect in many comets, but never at this intensity. Some teams have suggested that cyanogen, Cn, or ionized carbon monoxide, CO+, may also play a role, yet the dominant fingerprint remains C2. That's why 3I divided by Atlas glows such an extraordinary green. To compare, famous comets like Halley, which returns every 76 years, or Hale-Bopp in the 1,990 seconds, also glowed green, but never with this strength. In a sense, 3I divided by Atlas wears a kind of cosmic ID badge, unlike any other comet observed before. As of early October, 3I divided by Atlas is about 2 astronomical units from the Sun, roughly 300 million kilometers. That sounds far, but its speed is terrifying, nearly 60 kilometers per second, still accelerating. At perihelion, late in October, it could reach 68 kilometers per second. For comparison, Earth orbits the Sun at about 30 kilometers per second. This object moves twice as fast as our planet, fast enough to cover the distance from Earth to the Moon in just over an hour. Its current brightness is magnitude 12. That number may not mean much at first, but here's the deal. The human eye can barely see stars at magnitude 6. At 12, 3I divided by Atlas is 250 times fainter. Even seasoned backyard astronomers need medium-sized telescopes under dark skies. And here's the problem. As the comet grows brighter, Earth's window to see it is closing. By October 21st, the sun's glare will swallow it completely. That means astronomers are now racing the clock, desperately trying to collect as much data as possible before the comet vanishes behind daylight. When Earth's perspective fails, Mars steps in. On October 3rd, 3I divided by Atlas will sweep within about 28 million kilometers of the red planet. Close enough for spacecraft orbiting Mars to make critical observations, yet far enough to remain safe. The European Space Agency's Mars Express, NASA's MAVEN and Mars Reconnaissance Orbiter, and the ExoMars Trace Gas Orbiter will all have a chance to capture it. They can snap high-resolution images, analyze the gases escaping from its surface, and even measure how the solar wind interacts with its dust and plasma cloud. This opportunity is priceless. It's like Rosetta's famous mission to Comet 67P in 2014, but this time, the subject is not a comet from our backyard. It's a traveler forged in another star system. Comparing its chemistry with our local comets could reveal how alien planetary systems form and whether they resemble our own. One of the strangest features of 3I divided by Atlas is what astronomers call an anti-tail. Instead of pointing away from the sun like every normal comet, this narrow streak appears to extend toward it. Why? Normally, sunlight and solar wind push dust particles outward, creating that classic trailing tail. But if dust grains are large or electrically charged, electromagnetic forces can bend their paths in unusual ways. The result: from Earth's perspective, the comet looks like it's sprouting a tail in the wrong direction. This phenomenon is rare even among solar system comets. Seeing it in an interstellar object is astonishing. It suggests the plasma environment around 3I divided by Atlas is chaotic gravity, radiation, and magnetism, all wrestling for control. Computer simulations try to model it, but reality is proving much more complex. If Martian spacecraft manage to capture detailed images, those could unlock long-sought answers about the strange dance between dust and solar wind. 3I divided by Atlas isn't the first interstellar visitor. In 2017, Oumuamua surprised us, a cigar-shaped rock with no visible coma or tail, tumbling silently through space. 2 years later, 2I divided by Borisov arrived, behaving like a textbook comet, blue coma, water vapor, cyanide signatures, and a long tail. If Oumuamua was the dry shard, and Borisov the classic comet, then 3I divided by Atlas is the unpredictable outsider. It glows unnaturally green, brightens far faster than expected, and even hints at an antitail. Compared to famous local comets like Halley in 1986 or Hale-Bopp in the 1990 seconds, Atlas is even more baffling. Halley and Hale-Bopp came from our own Oort cloud, the icy shell surrounding the solar system. 3I divided by Atlas, in contrast, comes from a completely foreign system, possibly light years away. It's not just another comet, it's a messenger from another world. Why does this matter so much? Because objects like 3I divided by Atlas are time capsules. They carry the raw materials from the star systems where they formed untouched for billions of years. By studying their chemistry, brightness, and structure, we can compare them to our own comets. This might answer one of humanity's deepest questions. Are other planetary systems built like ours? Do they contain the same building blocks, water, carbon, organics that made life on Earth possible? Some scientists even wonder if interstellar comets could transport organic compounds across the galaxy, supporting the panspermia hypothesis. Whether or not that's true, 3I divided by Atlas gives us a once-in-a-lifetime chance to peek at alien chemistry. But the cruel twist? Just as the comet becomes most active, Earth's view disappears. That makes every hour of observation before October 21st critical. Eventually, 3I divided by Atlas will fade. It will sweep around the sun, shrink, and vanish back into the dark. Most of us will never see it again. But the data, images, and debates it leaves behind will shape astronomy for years. It reminds us that the universe is never short on surprises. Interstellar visitors are rare gifts, cosmic postcards from worlds we've never known. So, what do you think? Is 3I divided by Atlas simply a frozen relic from another system, or a clue to secrets we've only begun to imagine? Share your thoughts, and don't forget to subscribe to Why Is That Lab, because the mysteries of the cosmos are just getting started.